So we have like similar to probability density function, you have not similar, but the idea is that you have something called as cumulative function. Okay, in case of cumulative, what happens is, okay, we are adding the previous probability. So if you see this, between 2 and 4 the value was this, but if you want the cumulative distribution would be like this. The cumulative distribution will be, the probability is, this is a density function, right? Okay. And you have, what we have is, we have cumulative probability. Cumulative probability would be, right, till 2 the probability was how much? 0. Okay, and it is rising linearly. Okay, and till 4 it will rise and it will become, after 4 the probability will become 1, and what will be this number? This will be 1. So what we are saying is, this is a cumulative probability function wherein 0 to 2 the probability is 0. Okay, above 4 the probability is 1. Why? Because above 4 what you are having is entire x has already occurred. Okay, so if somebody, what is cumulative? Cumulative is probability of, let's say if you want to find out the cumulative probability of this number 2.5, it means that you are thinking from the probability up till 2.5. If somebody asks the cumulative probability of 3.5, you are finding out probability up till 3.5. Okay, so what you are seeing is, from 2.5 to 3.5 the cumulative probability will always be an increasing function. Okay, cumulative probability is always increasing function. So between 2 and 4 it is increasing. Okay, and it will become like this. So what you have is, this is a cumulative, right? So if you have fx as x, or we have 2 over here, okay, this is what fx is given. We want to find out the cumulative. So we want to find out that, okay, if you want a real example, okay, I will give you in case of discrete. Okay, maybe like discrete you will be able to realize. So what we have is, x can come from 1 to 6, right? I want to find out what is the cumulative probability of 2. What is the cumulative probability of 2? What it will be equal to? Let's take a case of throw of a die. Okay, let's take a case of a throw of a die, when in die you can get 1, 2, 3, 4, 5 or 6. Okay, I want to know what is the cumulative probability of 2. Cumulative probability of 2 can be written as probability that x will be equal to 1 plus probability that x will be equal to 2. Right? So 1 by 6 plus 1 by 6. So 2 by 6 or 1 by 3 is the cumulative probability of 2. Okay, so this is a case of discrete. In case of continuous, like you can say that cumulative probability is up, what is the probability of numbers coming up till that point. Okay, so that is your cumulative probability. Okay, so this is the diagram for cumulative probability for this. Okay, if you want to find out the cumulative probability for the throw of die, what you have is 1, 2, 3, 4, 5, 6. What is the cumulative probability of 1? Can I say it will be 1 by 6? What is the cumulative probability of 2? 2 by 6. Cumulative probability of 3? 3 by 6. Cumulative probability of 4? 4 by 6. 5 by 6. And it is 6. Okay. After that, it will be, for all the numbers, it will be 1. So 6 by 6 is 1. And below it, all the number, it will be 1 by 6. So here what we are putting is, we are putting on the, what you will have is, between 1 to 2, it will be 1 by 6, because till here 2 has not occurred. Okay, up at 2 it will become 2 by 6. From here it will be this, and here it will be a jump. Here you will be seeing a jump. Here you will be seeing a jump. Here you will be seeing a jump. So what you have is, cumulative probability of 1 is 1 by 6. 0, it is 0. So you will be seeing this kind of thing. Between 0 and 1 it is 0. At 1 it will become 1 by 6. It will remain up till just above 2 as 1 by 6. At 2 it will become 2 by 6, and it will remain the same up till 3. At 3 it will jump. It will become 3 by 6. Up till 4 it will remain as 3 by 6. At 4 it will jump. And so this is the cumulative probability function of, for throw of die. So this is how you have probability functions. You have cumulative probability function. Okay, and it's just like you will be getting in examination like cumulative probability functions. You will have to solve like certain problems over there. Now, what are the like common probability distribution we see? Okay, so I have covered discrete uniform distribution. Discrete uniform distribution, that is the throw of a die. Okay, so we are seeing the discrete uniform distribution. Okay, one more type of probability distribution you will see is binomial distribution. I will explain. We have also seen continuous uniform distribution. That is when we said fx equal to 2, it was a continuous uniform distribution. Then we have some distributions which we have to understand. Okay, that is binomial, okay, normal and log normal. So just let we will see this. Okay, now what we have is like we'll be spending a lot of time to understand this normal distribution. Okay, and binomial distribution, it's not necessary like in log normal also. Okay, so what we have is, what is binomial? Binomial is having two cases. Okay, by means two cases. So when you like think about when you are throwing a coin, okay, you can get a head, you can get a tail. Okay, suppose when you are throwing a die one time, okay, what is happening is it is called as one trial. Okay, so you have done one trial. Okay, however, if you are doing more than one time, okay, you have like 2 trial, 3 trial, like that. Okay, so what will happen is, okay, there can be there can be probability associated with the outcomes. Okay, so think about when you are doing one trial, you can get head or you can get tail. Okay, so these are the two possible outcomes. Okay, but when you are doing 2 trials, what you can get is, you can get this scenario. Okay, head head, tail tail. You can get head tail or you can get tail or head. Okay, so what will happen is, if somebody asks you what is the probability of getting, okay, head 2 times, okay, what is the probability of getting head 2 times when you are doing a trial 2 times, when you are throwing the die 2 times, can I say the probability of getting head 2 times will be 1/4? Okay, now when you are throwing one time, what is the probability of getting head 2 times? When you are throwing one time, the probability of getting head is 0. Okay, when you are throwing 3 times, what is the probability of getting head 2 times? When you are throwing 3 times, what is the probability of getting head 2 times? Okay, so when you are throwing 3 times, what you can see is head head head, head head tail. Okay, then head tail head. Okay, like that you can get scenario. So what you are having is, so think about it, you can get, you have to get 2 heads. Okay, either you can get this way, head head tail, or you can get head tail head, or you can get tail head head. Can I say that all of these are same? So here what we want is, we are considering a selection problem. So out of 3 times throw, we want head to come 2 times. So this is out of 3 times we want 2 times. So this is called as 3C2 combination. Okay, and what we have is, once we have got the number, so this number will be 3 times. Okay, so this 3C2 will also come as 3 into what we have is probability of head. So head is coming 2 times, so we'll say probability of head is 2 and the probability of tail is 1. Make sure that this 2 plus 1 should be equal to 3. This 2 and this will be equal. So what you are seeing is, you are seeing some kind of calculation of probability, and this is your probability distribution or binomial distribution. Okay, so when you are getting when you are throwing 1 times, head is coming 0. When you are throwing 2 times, head is coming 1/4. When you are throwing 3 times, the head is given as this probability. So this will be changing when the number of trials are changing. Okay, so you have some probability formula. So the probability formula for this is written as this: probability that x will be k, that means like head is coming k times, is given as n c k, that is out of n times k times head will come, okay, to the probability of head k times to the probability of tail n minus k time. Okay, now we can regard head as success, tail as failure. Okay, here we have like head and tail is coming as 0.5, 0.5, but take a biased coin where probability of head is 0.6. Okay, so what you can say is Okay, this is 0.6 to the power k, 0.4 to the power n minus k, like that you can have. So this is your probability distribution. This is a binomial distribution. Okay, we will consider one more type of distribution, which is normal distribution, but okay, this will be covered in detail. Okay, so normal distribution has certain probability. Let's try to differ this. Okay, in detail we'll cover. Okay, now there's one more distribution, log normal distribution. So when we cover this normal distribution, that time I will cover this log normal distribution also. So these are some common type of probability distribution that you can see. Now let's try to understand the next aim, that is the expected value. What is expected value? Okay, so expected value is thought of as average. Expected value can be thought as probability weighted average. So it's a mean. Okay, however, it's a probability weighted mean. So if somebody asks you what is the expected value, okay, let's say if I ask you what is the expected value of a throw of a coin, find the expected value when you throw a 6-faced die having number 1 to 6. Okay, if somebody asks you this, okay, what you will do is, okay, so for we say that, okay, the expected value, like you can have 6 numbers, 1 2 3, like that till 6. The probability of 1 is 1 by 6, so you can expect 1 to come 1 by 6 times. So this is your probability, this is the number. Then you have 1 by 6 into the number coming is 2, so probability is 1 by 6, the number coming is 2, so 1 by 6 into 2 plus 1 by 6 into 3, like that way you will be adding to get the expected value. So expected value formula is written as, expected value is summation of pi xi. Okay, so pi over here is 1 by 6, so each of these item had the probability of 1 by 6 and the number that you are getting was 1, so pi is 1 by 6, xi is 1, so 1 by 6 into 1 plus 1 by 6 into 2 plus 1 by 6 into 3, like that you will be adding, and ultimately you will be getting 1 by 6 summation plus 1 plus 2 plus 3 plus 4 plus 5 plus 6, so this will be 21 by 6, so you will get expected value of a throw of a die is 3.5. What you have is expected value can be thought of as an average. Okay, it's a mean. However, it is a probability weighted mean. So weighted mean is WIXI. So this is a probability weighted. So you are multiplying with probability. Okay. Now let's try to solve this problem. 7.1. Okay. We want to find out the expected earning per share of Infosys. Okay, earning per share, as of now, just understand it is some number. Okay, that is stocks have. So all the stocks have some earning per share number. So you have, okay, expected EPS. So we know that expected value is given as summation of pi xi. Okay, so what is the expected value of earning per share? So Vinith has given answer as 3.02. So over here what you will have to do is you have to multiply this into this equal to what, 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 and let's say this is A, B, C, D, then you have to take the summation of A, B, C, D, and that is your expected value. So here you have PI, this is your PI, and this is your XI. So PI into XI, okay, it will be A, B, C, D. So this is 3.025. So the answer is 3.025. Okay. Now let us try to understand some of the properties of expected value. So what are the properties of expected value? Okay. If you want to find the expected value, okay, of EKX, okay, so over here we were finding out, over here the expected value we are finding out EX, okay, when it was 1 2 3 1 2 6, right? So you had 1 2 3 4 5 6, we had computed it was 3.5. okay. However, if I am asking you a question that I have given that EX is 3.5, that is when X was 1 2 3 4 5 6, okay, the expected value was 3.5, but I am saying that now X is this 2 4 6 8 10 12. So the expected value is now this 2 4 6 8 10 12. I want to give you what is the expected value, okay, without like recomputation. I have given you the expected value of x as 3.5, what I have done is I have multiplied this 2 times. So I have given x, I want to find the expected value of e of 2x. Okay, so whatever x was, I have multiplied with 2. So if you do this, you can think of, you will be, each of them have the same probability, so pi xi. So now instead of pi xi, what you have is summation of pi into 2 times xi, right? So you can take 2 common and you will say summation of pi xi. Now this pi xi, you know, is expected value of x. So whenever you have x multiplied, so whenever you have expected value of x, it gets multiplied by a constant k. Okay, the outcome will become k times expected value of x. Okay, so this is one of the properties of expected value. So expected value ekx is k times ex, where k is a constant. Okay, and the expected value of x plus y, when your x and y both are random variable, okay, it is written as ex plus ey. Okay, so take an example wherein like you are finding out expected value of, okay, 1, 2, 3, and so this is x random variable, and when you have y random variable as, let's say, 4, 7, 10, okay, you can find out the expected value of x plus y, okay, by finding out this expected value first and this expected value second, adding that up. So the expected value of x plus y will be ex plus ey. So these are the theorems or the properties that you have to remember. Okay, so you can do the calculation and see. Okay, when you have, instead of what you are having is, okay, what is the expected value of a constant? Okay, what is the expected value of a constant? Before I go, what if I want to find out expected value of a constant? What it will be? So you are finding out average value of a constant. Average value of a constant will be constant itself. No, it will not be 0. Okay, so when you are finding out a constant, let's say I want to find out what is the average value of 2. What is the average value of 2? Or mean of 2? 2 expected value should be 2 only, right? So for a constant, the expected value will be k itself. Okay, so what we have is, now I have to find out expected value of kx plus b. So this I can write as expected value in this line as ekx plus eb. Okay, now we know that ekx is k times ex. So we have k times ex. eb we know at b. So we have eb over here, I can write as b also. Okay, so expected value of eb is b. Okay, so ekx plus b can be written as k times ex plus b. Okay, now when x and y are independent random variable, okay, you can write ex into ey as ex expected value of x into y as ex into ey. So you can find out ex and then you can put. However, if they are not independent, then it will not be the same. So for an independent, it will be ex into ey. For an not independent, it will not be the same. Okay, so the same way, if I want to take this reasoning, so what we have is, if I, instead of doing, so I want to find x into x. So what we have is, x and x are not independent, they are dependent, right? So as a result, I cannot write this as ex whole square. Okay, so this property comes from here. Okay, because x is same as x, so x and x here are not independent. Okay, so please note that you have to remember all of these properties of expected value. So these are the properties of expected value. Expected value is same as weighted mean or probability weighted mean. So let's move to the next topic, which is variance. Okay. Let's say expected value was 3.5, but you were getting number as 1, 2, 3, 4, 5, 6. So what was happening was, there was a variance. Okay, that means you are getting one term, sometimes 2, sometimes 3. So you are not getting the expected value. So what you were seeing is, you were seeing variability. So you are seeing variability, and the variability is mentioned as that what you have is the variability is mentioned as pi xi minus ex whole square. So what we are actually finding out is, if you see, when we found out the expected value, we found out summation of, so this is summation, we found out summation of pi xi. Okay, so this x is corresponding to xi. Okay, when we are finding out the variance, okay, so we are finding out the variance is, we are finding out the expected value of xi minus ex whole square. So we are finding out the expected value of this. So I will replace, think about this, can I say that this is y? Okay, so you are finding out summation of pi y. Okay, so can I write summation of pi y is expected value of y? If I written summation of pi xi as expected value of x, I can write summation of pi y as expected value of y. Okay, so expected value of y, so I can write this as expected value of y, I can write as xi minus ex whole square. So the variance of x is nothing but expected value of xi minus ex, okay, this entire thing whole square. Okay, now this expected value of x, many times you will be finding that they will write as mu. Mu means mean. So the variance can also be written as expected value of xi, okay, minus mu whole square. Okay, and if you find out this, okay, this is given, so I'll show you the formula. So this is given as ex minus mu whole square, and the outcome is ex square minus ex whole square. So just remember this. Okay, now the variance is the variability of data set around the mean. So variance is given as ex minus mu whole square. Okay, now what you have to think of is, okay, the variance formula is given as, okay, summation of pi, just remember this formula, xi minus expected value of x whole square. Okay, so this is the variance formula. Now what is the variance of a constant? We have found out the variance of expected value of a constant is k. Okay, so similarly I may be interested in finding out the variance of a constant. Okay, what is the variance of a constant? The variance of a constant is 0. Okay, now if I want to find out the variance of kx, so what you have is, you multiply every item by k. I want to find out the value where k is constant. So variance of constant, if you have, it is given as k square variance of x. So the variance of a constant is given as, okay, so variance of a constant kx is given as k square into variance of x, where k is constant. So please remember that in case of expected value it was k, in case of variance it is square, because variance has this square term. So this k will get, this here k is multiplying and here k gets multiplied, so k square comes outside, so it is k square. Okay, now variance of k plus x, where k is a constant, okay, is given as variance of x. So if you are finding out variance by adding a constant to the random number, okay, you will get variance of the random number itself. So variance is of a constant number plus random variable is variance of x. Okay, now if you are finding out the variance of a random number multiplied by a constant plus a random number, so we can first make this as variance of kx, and the variance of kx we can find out, because kx plus b, so it will go, b will variance will go as 0. Okay, so it becomes variance of kx. Variance of kx will become k square variance of x. So this is k square variance of x. Okay, now if you have variance of kx plus by, okay, where k is a constant, b is a constant, it is written as k square variance of x plus b square variance of y. So variance of x plus y, so think about it, before writing this I should have written this, variance of x and variance of x plus y is variance of x plus variance of y only when it is independent random variable. Okay, so I could have written variance of x plus variance of y, so I could have written variance of kx plus variance of by. Variance of kx is k square variance of x, variance of by is b square variance of y. So when k and b are constant, it is written like this. Now this is a very good thing, and please note that variance of x minus y is not variance of x minus, it is variance of x plus variance of y, because we are dealing with the squared terms and this minus whole square will become plus. So variance of x plus y and variance of x minus y is the same, that is variance of x plus variance of y. Okay, so this is what you have. Okay, please remember that this is a important thing and you will be getting one question out of it, so wherein you will have to, so they will give you some problem related to it, okay, and you will have to find out. So think about variance of x is given as 5, variance of y is given as 10. Okay, we want to find out what is the variance of 3x plus 5y. What is the variance of 3x plus 5y? Variance of 3x plus 5y will be equal to 3 square variance of x plus 5 square variance of y. So 3 square into 5 plus 5 square into 10. So 25, 250 plus 9 into 5, 45. So 295. So this is how you will be getting some question, which one question you will be surely getting, which is related to the properties of variance. Okay, so make sure that you are able to answer those questions. Okay, and this one type of problem which I do not expect, but it, like, since we are have to find, we have been given the formula for variance as xi summation of pi xi minus mu whole square. So this is one more problem which you can get, is computation of variance. So if such problem comes, you will be given the expected value. So this is the same problem for which you have computed the expected value, which you computed as, I think, 3.025. Okay, this is what you had computed. So this is given, expected value is given, you have to find out the variance. So what you will do is you will compute 0.35 into the EPS is 2.8 minus 3.025 whole square, plus you will do 0.3 into 2.9 minus 3.025 whole square, like you will be adding for all and getting the variance. So this will be variance. Variance is denoted as sigma square and sigma is standard deviation. So these are the properties of variance. Okay,